Okay, we're going to look at the worksheet called Calculus 1500 Related Rates. We're going to look at problem number 4. Problem number 4 says a person 2 meters tall walks towards a lamppost on level ground at a rate of 0.5 meters per second. So we have a person, and that person is 2 meters tall. The person walks on level ground toward a lamppost. I'm going to label the side on the ground x, and that means dx over dt is negative 0.5. That is in meters per second. We know that's negative because since he's walking toward the lamppost, the value of x is decreasing. The lamp on the post is 5 meters high, so we're going to draw our lamp here. It's a fabulous lamp. And that lamp is 5 meters high. How fast is the length of the person's shadow decreasing when the person is 3 meters from the post? Alright, so basically if you can imagine, this lamp is going to cast light. Let's make our light green. This lamp is going to cast light over the man's head. It's going to cause a shadow to form over here on the ground. Yes, the man has a green shadow. Do not ask why. We're going to call the shadow, we're going to call it S. And what they've asked us to find, ds over dt when it says how fast is the length of the person's shadow decreasing when the person is 3 meters from the pole. So that is when x equals 3 meters. What's important to know about this shape right here is that we have two similar triangles. We have a triangle over here that's formed by the man's height all the way down to the tip of the shadow and all the way up to the man's head. Then we have a bigger triangle that's formed from the lamppost down to the ground, over to the tip of the man's shadow, and then back up to the lamppost. These two triangles are similar, which means that their sides are proportionate. So we can set up an equation here. The man's height over S is equal to the lamp's height over S plus X. S plus X is the length of this whole side. Whee! All the way over here. So that's this side divided by S plus X, and that's equal to the man's height divided by S. That's how similar triangles work. Now I know that I'm going to have to take the derivative of this, but I also see that it's got some fractions in it, and I think that you guys know how I feel about fractions, so I'm going to try to get rid of them. Let me rewrite my equation. 2 over S equals 5 over S plus X. To get rid of the fractions, we can cross multiply. So 2 times S plus X, 2S plus 2X equals 5 times S. It's important in problems like this that you try to make your 5s look different from your S's, or you'll get completely lost. Now I'm going to put all my S's together, and then I'm going to take myself a derivative and call it a day. So if I subtract 2S from both sides, I find that 2X is equal to 3S. Now on the previous screen, let's see, they already told us that dx dt is negative 0.5, so we're going to need that in a minute. Let's take the derivative of this. 2 times dx over dt is equal to 3 times ds over dt. They told us that dx over dt is negative 0.5, so that's 2 times negative 0.5 equals 3 times ds over dt. Now they asked us to find ds dt when x equals 3, but you can see from our equation that we don't even need that information. We can just go ahead and solve for ds over dt as it sits. So negative 1 divided by 3 is ds over dt. We are going to need some units for that. The length of the shadow is in meters, and time is in seconds. So ds over dt equals negative 1/3 meters per second. Yay!